Chapter 4, Section 12, Microbial Life in the Cold. The Extremophiles. Okay? These are going to be things that want to grow where really nothing really should be wanting to grow. Organisms that grow very hot or extremely stupid cold. And I say extremely stupid cold because it's middle of winter here and it's just freaking cold. Got to remember, a large portion of Earth's surface is cold. Oceans, North Atlantic, South Pacific, down around Antarctica. Oceans are going to be just above freezing. Some of the times they're going to be below freezing, but because of the salinity, they just don't freeze solid. You're still going to see microbes growing. You're still going to see organisms, prokaryotes and eukaryotes doing very, very well there. Which organisms? Well, it depends on whether or not that area you're looking at, area you're wanting to describe, is constantly cold or seasonally cold. If it's constantly cold, there's going to be a set of organisms that are there all time. Seasonally cold, well, who's there and what's the number of their population will vary, as the temperatures vary. Here they're showing an ice core sample. I believe it's from Antarctica. They drilled down into the ice. There's microbes there growing in Antarctica. Yes, it's cold, but hey, guess what? There's still life there. The psychrophiles versus the psychrotolerant. The psychrophiles, these are going to be the boys who, 0 to 20. Too hot, too cold. They're just right. It's going to be 15 degrees Celsius. 15 degrees Celsius. Yeah, it's going to be about 45 degrees Fahrenheit. I'm just doing the math in my head there real quick. These are going to be found polar regions, permanent snowfields, glaciers. The temperatures may dip down to close to 0 and below during the times. Well, these psychrophiles are going to metabolically slow down. It's not always going to be this cold. Sometimes it's going to go just above freezing. Boom, these guys go metabolically active again. You're going to have the psychrotolerant. 20 to 40. Yeah, but you know what? They can handle every so often it getting down to 0. They're not going to thrive like the psychrophiles. They're just above temperature range of the psychrophiles, but they can handle it. And when it gets down to there, it's going to slow them down a bit, but not completely. You look in some snow up, in the north there, and they'll find algae growing in the snow. You'll see pictures of, icebergs and whatnot that are floating down, and they have a red tint to them. Turns out that's algae growing in the ice, growing in the snow there, that, made up the iceberg, or it's on top of the iceberg. Turns out this is an adaptation that took millions of years. This isn't just ooh, hey, it's Tuesday, I think I'll go up to the North Pole. The slow selection of these microorganisms that are the psychrophiles and the psychrophile tolerant means that the mutated species over, the hundreds of thousands, millions of years, there's been a selection towards organisms that have more alpha helices versus beta sheets in their proteins, in their enzymes. Turns out having greater percentage of alpha helices, greater flexibility at cold temperatures. Means their enzymes can still function even when the temperatures drop to their minimum or just below their minimum. More polar and few hydrophobic amino acids. So they're there's going to be a complete change, a complete difference in what their proteome, their collection of proteins looks like compared to something that's growing up, say, here, Midwest. Yeah, we get cold for parts of the year where it fits that temperature profile, but then again, we also get really stupid hot. Proteins of soil microbes here is going to be completely different than the protein, characteristic proteins of ones growing up, near the North Pole, South Pole, as we're seeing here.